Ahmad, you have the floor.
Okay, so good morning, good afternoon, and good evening, everyone. First of all, I would like to sincerely thank you to the host for giving me this opportunity to share knowledge and connect with such amazing global engineering community. This is actually my first session with the SolidWorks user group community, and I am really excited to share some insights with you. So let's start. So
Okay.
I
Muhammad, before you start, I really want you to give a small intro about who you are, what's your level, because all of us know that you're a
okay.
certified SOLIDWORKS expert, but it's always very nice to always start with that. And please, before you continue, if you have any question, please just leave it in the comment section. And by the time Mohammed will be presenting, he will have some time to jump in and answer your questions to see. So, Mohammed, you have the floor.
Okay. This is actually my first session with SolidWorks user group, and I'm really excited to share some insights with you. In this session, I will try my best to cover the fundamentals of SolidWorks assembly modeling, starting from basic concept to starting from basic concepts of mates and assembly structures, and we will touch some advanced assembly topics and techniques that can make your workflow more efficient. So if you have any question or queries, you can drop in the chat section. Okay, we will collect them and discuss them at the end of this session. First of all, this is my before we begin, this is my quick introduction. My name is Huzaifa Aftab. I'm a sixth semester mechanical engineering student, and I'm honored to be recognized as Pakistan youngest SolidWorks expert and champion. It's truly an honor to be here with all of you today. I have founded a WhatsApp-based community, which name is MacMate Hub, to mentor fellow engineers and my junior to help and build the clear roadmap for mastering CAD software. So, first of all, this is the basic concept about the bottom-up and top-down assembly. What is bottom-up assembly, first of all? It is the traditional method in which we create individual parts first and then bring them into an assembly to mate them together. It's similar like to building something with like Lego blocks, where we can make pieces first and then put them together. So you can see in the slide like we made that a part first and then uh, we assemble them in the assembly. Okay. So second one is you can see that two parts, and second is top down assembly. So in top down assembly, you start working directly inside the assembly. Part are designed while considering their relationship with the component. So this means if the main or master part changes, the related part update automatically. You can see in the picture like there's a bench wise. We can make the side part inside the assembly. So this is the top down assembly. So then we go to the fixed versus floating component. So when we first bring a part into assembly, it is crucial to understand the state of the assembly. Okay, so by default, the component placed in a uh, fixed is sorry. So by default, the part is placed in a fixed state, so all subsequent part are floating, meaning they have 6 degrees of freedom. So you can right click any component to toggle between these states. If you can't move the part, check the features. If you can't move the part, check the feature tree. If there is F sign next to it, it is fixed. Like we can see that in the first picture, there's a minus sign, which means that this is the floating component. So we can right click on this part, and then we can click on the fix option to make that part fixed. So meanwhile, in the second picture, you can see that this is the floating component. So we can click on float to make them float. Okay, so next one is a temporary and the fixed group. So sometime when we are working with complex assemblies, so like a robotic arm, there are like many moving parts in it. So if we try to make move one component, other parts may also move. So which can be confusing. So the temporary fixed or a group tool help us to quickly lock certain component in the place. This allow us to focus on testing the like the movement of the specific part of the other component without moving the other part unnecessarily. So we can right click on that part, and then we can simply click on the temporary or fixed group to make them like temporarily lock them. Okay, so next are the mates. So now let's talk about the mates. Like this is like a type that holds everything together. Like this is a critical part of the assembly modeling because they define how part intersect and move. So what are the mates? So think them like this is a geometric constraint, just like a relation in 2D sketch, the relation of vertical and horizontal relation in the 2D sketch made create condition between 3D parts. uh, like we can simply select two or more faces, edges or vertices. So then we build a constraint. SolidWorks tells which part exactly how sit or align together. So you can find the mate command in the symbolized by the like a paper clip icon under the assembly tab. Okay, so mates tell the part how to touch, align, or move together. So next are there are the list of some standard mates. So SolidWorks offer variety of standard mates. Like we use the most of the time these standard mates, which are the coincident mate. Second one is parallel. Third one is perpendicular. Then tangent mate. Then concentric, and the angle mate. And lastly the log mate. So what is the parallel or perpendicular mate? Like it set the angle between the two surfaces. So almost all of these are 3D version of same geometric constraint under in sketch relation. So we can find in this assembly section. Okay, so first one is coincident and parallel mates. So on the left side, you can see that a coincident mate is used to make two part to touch two faces. So on the right side, you can see a parallel mate that ensure the faces that stay facing the same direction even if they are not touching. So like we can watch our mate alignment, like we can flip the orientation using the aligned or anti-aligned button if the part end up or upside down. Okay, so this is the coincident and the parallel mate. So next one is perpendicular mate. So perpendicular mate is when we have to make two parts tangent to each other. Perpendicular is essential for like ensuring a 90-degree relationship between two parts. Like you can see that the bracket meeting the base plate. So tangent is what you will use when you need a cylindrical part like a roller or a pin to roll along like a flat or a curved surface. So these are the basic made from the foundation upon which all complex mechanical movement are built. So next one is the tangent mate. So now there's a concentric mate. So this is also a standard mate. Like we will use it in for shaft and bolts and when where there is holes. So it aligns the central line of the two cylindrical or spherical entities. so they can share the same axis. So on the right you can see there's a lock mate. Unlike other mate, they allow for some movement, like it allow you for only for rotation. The lock mate fully fixes the position and the orientation of two components which we are mating. So it is essentially like welding the part together in the digital assembly. So next one is the distance and the angle made. So when we need more than just a simple contact, we use the distance and the angle made. So in the distance made, we allow a specifically precise gap between two entities, like such as keeping a two plate 1 or 2 inches apart each other. So we can use that distance made. So the next one is angle mate. Like it works similarly, but for rotational orientation. So like we can define a specific degree of separation between two faces. Both of these are powerful because they can use as a limit mate to show a range of the motion. So these are some standard mates, and then there is one thing which is mate alignment. Like a common point of confusion in the mate alignment, most geometric condition like a coincident mate result in two parallel orientation of the parts. By default, SolidWorks choose the orientation closest to where you place the part. Okay, so we have to rotate these two parts, and then we have to make the part. So however, if your part end up inside out or facing the wrong way, you can easily use align or anti-align mate in the mate dialog to flip it 180-degree without deleting the mate. So this is the benefit of mate alignment and anti-alignment in the assembly. So next, there's the list of the advancement. So once like we master the basic, we move to the advancements. Like these tools often do the work of multiple standard mates, but with more intelligence. Like for example, the mate, like the width mate is a fan favorite. It centers one part between two faces, another part automatically. So in advanced mate, we can use a profile center for centering shapes, symmetric for mirrored movement, path mates to constrain a component movement along a specific line curve. So these are the list of the mechanical mates. Mechanical mates are where we move beyond the simple geometry. Like we defining a true mechanical function. These mates allow us to stimulate like a real world machinery like gears, cam, rack and pinion, etc. Like just instead of making face touches, we are telling SolidWorks when this gear turn 360-degree, the gear must turn 180-degree. It allows for like a high level functional simulation right inside the CAD environment. Okay, so these are our hinge mate, gear mate, rack and pinion, screw mate, universal joint. So these are the list of mechanical mate. So you can see in the slide like how cam mate works. So this is like a specific example of a cam mate. This can be used to create a relationship between a cam. So you can see again how we like we use the cam mate to make the relation between these two parts. So next one is the slot mate. Like it is useful for the linkages and like a sliding mechanism. It constrains a pin or a bolt to stay within the boundaries. So we have to make some boundary to make the slot mates. So we can set it on a pin is centered in a slot, like free to move between the ends. So this is actually how the slot mate works. When we made the component and then stimulate, it can like move in a specific path. So also you can see that the pin in the slots when we made using slot mate. So next one is the hinge mate. So like it is a great time saver. Like normally we can create a hinge. We need two mates. First we made a concentric mate along the axis, and then coincident mate to stop the part from the sliding up and down. So without using these two mate, we use the hinge mate to combine these two mate in a single command. Our feature manager tree looks cleaner, and we build our assembly very faster. So we use hinge mate in it. And okay, sorry. So that way we use the hinge mate, and you can see the video how this hinge mate works. So this is the hinge mate, and next one we have the gear mate. Like this create a rotational link between two components. So we do not need actually model like a gear teeth to perfectly work. For this work, we can simply select the cylindrical faces or edges. Then we define the ratio or pitch diameter in the gear mate. So it perfectly used for testing like complex gear train, including a bevel gear and an internal ring gear as shown in the slide. So after stimulating how this mate work. So these are the mechanical mates and advanced mates we discussed. And then there are some common assembly mistakes that we have to avoid in the real tree for getting no errors. Okay, so the most common mistake we do in the assembly is the over defining. Like we adding two mates that contradict each other, or leaving the part underdefined, so they can move unexpectedly in the assembly. So remember, all your mates are stored in the mate folder in the bottom of the tree. So we can always go back, right click and edit or flip the alignment if they are not working or planned. Okay, so common mistakes you can see in the table. If you see a red error, you likely okay, so this one. So if you see a red error, you likely have the overdefined mate where too many constraints are fighting for a same direction. Like we are 2 to 3 mates in a same direction, so this error will come. So next one is a yellow warning often indicates a conflicted mate that cannot be solved. So always check your feature manager tree for the symbols. Sorry. So if there is F written, so this we can say that this is the fixed part, and that cannot move. And if there is a negative sign, this is underdefined, we can still move the part in some degree of freedom, or in some direction. So, and the next one is plus sign, which is fully defined. We can say that the part is perfectly constrained, and a fully defined part. So now we will move to the practical workflow. So we combine all the techniques to build the complex linkage and the mechanical assembly. So let's move to the final practical workflow. Okay, so my screen is visible.
Yeah, Muhammad, yes, your screen is visible. I think it's visible for me, so it's visible for everyone.
Okay, so we will make this linkage assembly, and we use all these standard mate and some of the advanced mate in this assembly. Okay, so first we need a linkage base. So in most of the exam, you have to align the base part with the origin. So what we do, we go to this visibility icon. So after on this icon, we can click on to the view origin. So when we click on the view origin and then we place the linkage base part, it aligned perfectly with the origin. Okay, so we can get the correct answer after aligning with the origin. So after aligning the base part with the origin, so we insert different components we need for this linkage assembly. So we need this linkage board. So we open these components. You can see that there's origin with part is aligned with origin. So first of all, we use the basic mates to mate this bolt with this linkage base. So first of all, when we select this circular face and this circular this this inside circle, so you can see that in SolidWorks it automatically goes to the concentric mate. So when we click on that, it automatically made this with this part. So we can see that this is moving out of that. So then we need another mate which is coincident mate to mate these face with the linkage face. So when we made these two parts, now this part is fixed, and we can see in our feature manager tree that there is a sign F which indicate that this part is fixed. Okay, so we need to mate another thing with that. So then we use this linkage coupling to couple this with the linkage board. So again we use the concentric mate. So when we click inside this circle and this face, it automatically mate with the board. So this is moving up and down. So we made this face with this face to make it align with that face. Okay, so then let me check how can okay, then we insert the next part, which is the linkage cylinder. So we insert the linkage cylinder. So we now need to add mate with this. So we made this bolt with the linkage cylinder that way, and we choose the check mark to okay there this command, and then we select this face and this face to properly align with that linkage face. So it is moving in like it is rotating, but it is not moving in z and z in z direction. Okay, so then we also made this part with this part. Okay, and this bolt we made this face with this face. This is coincident made there. So now these parts are made together, and then we insert the next part. So this is basically okay, so the next part we need another linkage coupling there and another bolt there. So we put together.
Yeah, I think Mohammed should have some small issues. Yeah. Le- Before we get back to the presentation, like I was saying, if you have any question,
Okay. Oh,
ask the
sorry,
question.
my
Yeah, I
internet.
understand. I
So
understand.
my voice is clear.
Mohammed, please give me a minute, let me finish. Yeah, your voice is perfectly fine. Yeah,
Okay.
like I was saying, if you have any question and you feel that you cannot articulate it in a comment, you just make a request and I'll give you the mic and we can discuss together. You understand? Um, so Mohammed, you can keep up with the presentation.
Okay. So we have to make these two linkages. So again, we use mate command and made these two faces. Made these, sorry, not these faces. We made this inside circle with this bolt, and also this bolt with this inside circle. So, and then you can see that this is moving in z direction, so we need another mate. So we made this face with this face to not move. So you can see that now this part is fixed. And to fix this bolt, uh, we select this face with this face, and now this is fixed with this linkages. So now we need two more parts to complete this assembly. So we need the linkage piston, need the linkage, and also another board. So now we can use the copy made assemblies. So how can we do? So like if you click on the S command, if you click on your S on your keyboard, and then we search copy made. So this is, you can see there's a copy mate, copy components with your mate. We can add this for our we can easily do by clicking S. So I add this in my quick command. So I click on the copy mate. So then I need this bolt. So I click on this bolt, and then I click on the next. So they say you have to repeat the concentric mate 2 or 3. So I need only one mate with this face, so I click on this face, and then I click on the check mark. So in that way we can easily copy the component without going in again and again into the assembly. Okay, so now we can also made this with the advanced mate, which is a slot mate. So we use in the next option. Okay, so now we made this piston. Like we have to make this face with this inside face to make it properly align with that, and then we click on the send circle and this bolt. So now these are properly selected. So now you can see that this bolt is not moving in this slot. So what we do there, so first we made this face with this. Okay, so we want to move this piston inside this linkage cylinder. So you can see that now it is not moving because I use the concentric mate. So what I do, I delete this mate and I use the advanced mate, which is sorry, a mechanical mate, which is a slot mate. Okay, so I click on the slot mate, and then I click on this circular face and this inside face. So now this will move in inside this uh, in this linkage base. So okay, so where is it? So we have to delete this concentric mate, and we can see that this is moving inside this linkage base. So we need to move this inside this slot. So we use the slot mate there to move this bolt inside this assembly. So now we made this piston with the bolt, this circular face and this circular face, concentric made there, and then we have to make this. Okay, now this piston is moving in this slot. So now we have to make this face with this linkage cylinder to make it straight, and this can move easily inside this cylinder, piston in cylinder. Okay, so now what we do, the last thing, this circular face with this bolt face. So you can see that we made all the things. And now you can see that this linkage is moving inside this and outside. So you can see there that this piston is moving outward from this cylinder. So there what we use, so we use another mate, which is the distance mate, to make a distance between them. So again we go to the advanced mate. So we click on the distance mate. Wait, sorry. Not wait, we used advanced mate, and then we go to the distance mate. Where is it? Okay, so we go to the advanced mate and add a distance in these two faces. So you can see there, this is the maximum value and this is the minimum value. So how can we find that what is the maximum value inside this hole and what is the minimum value? So we can measure this, like you can see that this close inside this hole. So what we do, so we specify the values there. So first we select this face and then we select this inside face. So wait, how can we select this? We can move it backward and then we can see that this inside face, we can click on this face and then this face. So you can see that it made with this one. So now we add some distance, maximum and minimum distance between these two mates. So from there, when we have the distance of that, we specify the distance like 20 millimeter or 30 to make these two components. So this is the complete workflow. How can like we made this linkage assembly. So wait, I can specify the distance there. So this is 1 millimeter. We can add more with that. You can see that when I change the distance, it move along that distance, and like we have to make on the 150, 140, it will made there. Okay, so this is the first question of how we can make the linkage assembly. So that's is the first question. Then we go to our next question. If you have any question in this part, you can ask. So I can check. Okay, if anyone has any question in this this assembly, so you can ask.
Any question you can ask, and if there is no question, you can continue.
I will like to know path mate. Okay,
Yeah,
so how can we make a path mate? So for the path mate, you have to specify the component vertex. So I have to make if there is any path, we have to follow that path. We make the sketch there, okay, and then we select the path from the path selection to make the like a path made there. Okay, so I have no assembly right now that I can give you the like a practical view of the path mate. So for the path mate, we have to make like a component vertex, and then we select that path. Like if there is some line or some curve we have to follow, so we select that curve, and like a square box we have to move on that path. So that type we can use the path mate. Okay, so I am sorry because I have no question related to path mate. Okay, right now. Complete the limit distance or piston not outside the cylinder. Okay, so how can we complete the made distance? So first of all, we have to know what is the distance from this face to the inside face. So how can we find the distance? We can use the evaluate tool to measure the distance between two faces. So from that face to like we can say that this face. So we find the distance between two faces. For that, we use the measure tool. We select the inside face and then this face. So we can see that there is 200 millimeter maximum distance. Okay. So what we do, we again go to distance mate, features. We specify the distance made 200 millimeter. Okay, so okay, now I think this will work. No, so we again give the distance mate. So how we can use, we click on the mate, we go to advanced, we will select okay, so we will select the inside face, which is this face, and then we select that face. So we select these two faces, and then we select the minimum and the maximum distance. Maximum distance is 200 millimeter. Okay, and the minimum distance is like we put 0 millimeter. Then see what happens. Okay, so now when we move this piston into a cylinder, this will move up to 200 millimeter, and then it will come at 0. Okay, so you can see the from the transparent view, this will go to its maximum value. Okay. So in that way we can use the distance made. If we know the distance, we can easily use the distance made. Okay, so moving to the next question. So this is the complete linkage assembly. So it will move to the maximum position and the minimum value. So in this way we can use that. So next question is the next assembly question. Nice to see you. Okay. So now we will go to our next question. So this is the base part. Oh, sorry, this is not a linkage base. Inside component. Okay, this base part. Okay, so now we want to align this base part again with the origin. So what we do, we select view origin and also the view coordinates. Okay, and then what we do, when we point our cursor on the origin, so you can see that when we point on the origin, this can clip the origin. Okay, so in that way you can align your assembly or a base part specifically with the origin. So now we need to add some more parts in it. So how we add, we need the connecting rod, we need the connecting block, and lastly the wheel component in it. So we insert all this is the connecting block, and last thing is wheel. So now we have to first of all we have to made the wheel with these two faces. So what we do, again we use the standard mates to make a concentric mate between these two faces. Look, in that way, and then we will mate this face with this front face to come to match with our reference assembly. So you can see that we allow it to move rotate, but not in Z and Y direction. Okay, so it is locked in Z and Y direction. So again then we click S on the S key, and then we use the copy with mates command to copy this wheel with mates. Okay, we select the wheel. SolidWorks automatically tell us what type of two mates you use, concentric and coincident. Then on the first we select this face to make a concentric mate, and then coincident mate we select this face. So it is very easy for us to add mates with copy mates. So you can see that we add wheel on that place, and now we need two connecting rods. So first what will we do, we made this connecting rod, this inside face with this circular face. So like how these two faces connected, because the inside face is like that which clip the circular face. So that's why their concentric mate is used, and it automatically made this part. Okay, So it will move in 2 to 3 direction. So for that way we need a connecting block. Okay, so again we use copy made command because we need one another connecting rod. So what we do, we press the S key, we use the copy with mates command, we select that connecting rod, then we go to the next, and then we select this circular face, and that's it. This will automatically made with this one. Okay, so now for our last thing, we have to make this connecting block with these two faces. So we see in our slide that the first part we insert is fixed. You can see that with the sign F, the base is fixed, and all other thing is in the floating state. Okay, so like we can move there by using any mates. Okay, so what we do there, we select this face and this face, and this face with this face.
Yeah, it's like it was connected to the hidden line, the center line, the connecting block. Check it.
Okay, so now what we do, we do another mate with this face with that face.
Yes. Mohammed, I think there's an issue with the first mate you connecting. At the level of the connecting block, what you will see is that it's actually connected with the center line. Go and check it out.
Okay.
First, yeah, you saw that it's connected with the center line. I'm not considering it. Oh, that was what you were trying to do. Go to the coincident to me.
Oh, sorry, I make this coincident with that face. Okay. So this is that I do wrong, that's why this is not made with this part. So now we use the concentric mate, this circular face with this face, and this circular face with this face, and then we made this face with that face, and this face with that face. So now this connecting rod assembly is completed. So when we move this wheel, this all the things will move with that assembly. Okay, so in that way we use some basic mates, most of the basic mate, and little advanced mates. So if you have any question in this this one, you can ask. So these are the two assemblies we do in this session. So if you have want to do this question, I will share that question. You can you will practice that question at your own. And thank you for your attention. So feel free to connect with me on LinkedIn. So that's it.
Wonderful presentation, Muhammad.
Okay.
And we are still taking the questions. If anyone has a question, you can just let us know.
So,
Okay, there's one thing here from Usman. Kindly share the path for practicing assemblies. Okay, so Usman needs the path. And there's a question from David. Is concentric made the best for spherical parts? Nice question.
yes, yes, we mostly use concentric made for spherical part, but we need to make like we have to make the two parts. Like in this, you can see that in this wheel and this there is a space inside it. So first we have to make a spherical like a section inside it. Then we can easily made the like a circular spherical part inside this connecting rod. So wait, when I make this transparent, you can see that we firstly make this part like that, so we can easily make these two parts. So
I think you need to first of all switch to your SolidWorks screen.
oh, okay. Sorry. Okay, wait. Okay, now you can see my screen.
Yeah, you can see it perfectly
Okay,
fine.
so what we do, like in this concentric mate, the like a connecting rod. So we first have to make the connecting rod like that. This concentric mate will work. So if we use the circular command, it will not work. So we have to make like a section inside that, so it can easily mate with each other. Like you can see in this part, we make like this like a spherical, so it can easily mate with this spherical circular body. Okay.
David, did it answer, did the explanation
What
answer your
remote
question?
that
Or do you need more clarification?
can tangent meet also? Yes, tangent and tangent. Okay, so we try to make a tangent mate there, but I think it will not work. We use the tangent mate at that place where is there is some like a straight face, and then there is a circular face. So we use the tangent mate there. So I think a tangent mate will not work there. Okay, we try to make a tangent mate there. So we delete that face, make this transparent. So now we try to mate it with the tangent mate. Okay. So for tangent, you can see we need like a straight face to make it tangent with the face. Okay. So I can share my slides. You can easily form that tangent mate. Tangent. Okay, you can see there we use tangent mate at that faces where there is one straight face and other there is a circular face. So we use tangent mate in that condition. Okay, so we can't use there with the circular face as a tangent mate. Okay.
Okay, David, I found your mic.
Yeah, so I was just asking like for the tangent mate because like I looked at it like the face of the sphere and I looked at the circular place. So I was thinking maybe tangent mates can work. Then also in situation like this picture that you just showed, then let's say imagine it was a sphere that is sliding on this, like the sphere can rotate in different axes in the X, Y, and Z. So how you be able to just constrain it that is just only like in a particular axis without the other axis rotating on it? How you just be fixed like just moving straight in the X axis like that?
Okay, okay. So we use tangent mate in that situation where there is one straight face and other like a cylindrical or a circular face. Okay, so in that particular question, like I think we don't use we can't use that tangent mate there because both the faces are like a circular faces, so we use concentric mate there.
But I
Okay.
think I think he was more asking about the question he wanted to ask is, given that, let's say we take a circular ball and we place it on a flat plane, and David, you will help me if I'm mistaken, if I'm not getting it well. In fact, he was asking for which kind of mate can constrain it to make it fix on the plane. And that was the second question because the first one he was asking was,
Okay.
could the tangent mate
Mates
work
and
with the could the tangent mate work with the spherical part? In fact, what you
okay.
use to connect.
Wait, we make two parts and then we use the tangent made there. Okay, so
Yeah.
first,
No, let's
so
first of all go to your example, this example that you took. You see, in fact, what he didn't understood was the fact that they have the same radius. They have the same radius. They have the same internal radius. That's why they can be concentric. David, I hope you're getting the explanation. They have, if they didn't have the same, when I'm talking about internal radius, I'm not just talking about internal radius, but I'm talking also about the curvature. I'm
yes,
also, yeah, also talking about the curvature. They have the same curvature. That's why they can be concentric, even if they
yes,
have a small radius
exactly.
size as compared to each other. They still can be concentric because they have the same curvature. So here is mostly, in fact, it's mainly about curvature. You see,
Yes,
and if you can just open that part separately, the part that is
yes,
Muhammad, can you just
exactly.
open the green part separately,
Okay,
like open it to a new window, and let's just examine the curvature on this side.
so
Yeah.
you can see there is a curvature inside that. So that's why there we use the concentric mate. Okay,
Yeah.
so the tangent mate is not possible there. So I tell you before that we use tangent mate in that conditions where there is one straight face and other cylindrical or circular face. If you are asking that we have to fix once like a cylindrical face with the straight face, we need like two more parts to fix that. Okay.
Yeah. So, David, did Muhammad finally answer your question? Is it all right? Or
Yeah, I understand. But now, like, yes, quite all right. I understand that this is what you're meant to use, the concentric mate. But what in the situation, in a sphere, the sphere is just
yeah.
like a ball and socket joint. The same way your hand is, you can rotate your hand to any direction you want. But how you be able to constrain the movement, maybe to just one single axis,
Okay. So
just like your hand. You want to move your hand straight. It's a spherical joint. It can move to any direction, but if you just want it to move only maybe like straight in an x-axis, move just up and
Like
down.
to rotate, just to rotate, or you just want it to move up and down? That's what I want to know.
Yes, just to move up and down, it can rotate in a particular axis because once it's spherical, it's free to move any direction you want it. So how you be able to constrain it, whether it's just to one direction or distance. So that's all I wanted to know. Is there another mate that you add to it?
Okay, I'll just take you a simple example. Muhammad, can I take an example to
yeah,
explain it to
yeah.
you?
Okay. Go ahead.
David, do you drive?
Yeah, I try.
Okay, when you use how can I call it? Una person, sorry, in French they call it la boîte de vitesse. But in English, I think it's something, I've forgotten the name, sorry.
The
When
stick,
the what? Yeah, come again.
the drive stick.
Okay, let's call it the drive stick. Okay, when you use the drive stick, we can no more call it a ball and socket joint. You understand? Because ball and socket joint are They are called ball and socket joint because of their axis of rotation. In fact, that the freedom of movement, the freedom of that, the axis of rotation, the direction of that. But now, if you want to constrain it to a certain path, it's no more a ball and socket joint, but you can create it from a ball and socket joint. You understand what I'm talking about? Meaning that what? At the level of the, let's say you are going to arrange the path in such a way that you restrain some of the degrees of freedom, meaning for it will not be capable of rotating, but it will just move one way or other. You understand? Can you get me?
Yes. So that is like that constraint. How will you constrain it like inside SolidWorks? That's what I'm asking.
That constraint inside SolidWorks. No, you will just create. In fact, what will constrain it is actually the let's say the socket, if I can call it like that, the form of the socket. It's not actually something that can be created in SolidWorks. So it's not actually something that can be made in SolidWorks, like constraining the different part from something that is already there. Apart if you are using center lines. You understand? If I am using center lines and I'm directing the path from a center line, then you can do it. So that's also an approach. Muhammad, am I correct with that?
Yes, exactly. Okay, so
Please let me add something. But when it comes to design and intent, you see, most of the time I will not recommend someone to use center line to just show the path, because when you are actually designing, you are designing for engineering purposes and you're not designing just to show off. So using center line is not bad. You have your direction, but it's not really the, let's say, the design for manufacturing that we need. So that's just that. So go on, Muhammad.
okay, so like if we want to move this one in every direction, like in X, Y, and Z, we have to break these mates. Okay, so in this particular example, we have to fix the this. Okay, so if we have to move this in every direction, we have to break first these mates, and then this will move in in like in X, Y, and Z direction.
Yeah, but the thing I'm looking at like does look like the ball and socket on the right. So you can see, let's say if this one is facing vertical, the ball and socket on the right is facing horizontal. So can't both of them not face the same direction, even if it's a ball and socket and it's free to move to any direction it wants as they are rotating it or turning it?
Wait, I
I
will.
couldn't get the question. Please.
Okay,
Muhammad,
wait.
you get?
I think he's saying we can move this ball and the socket in any direction. I think he's saying like
Yeah,
that.
I'm saying like the green joint that is there. So you can see like this is vertical, then the one on the right is horizontal. So why can't both of them not be facing vertical?
Okay, wait.
Oh,
Yeah.
okay.
So
I think,
because it's a ball
yeah.
and socket joint, so the something can move to any direction you want. So that I was asking like, was there a way you can be constraining it as you are, maybe even if it's rotating, can't everything not face vertically? Must one be horizontal and the other green side is vertical inside the ball and
Oh,
socket joint?
no, but it's impossible. That's why it's a ball and socket joint now. Can you get me? Like from there, see, from there, it's not that one is not really a ball and socket joint. You understand? Because a ball and socket joint is more something that's like that, the socket, and now you have the ball like that. You understand? And now it can rotate, and now it can displace itself in other direction. But here we have a different representation of this based on what
Yeah,
Muhammad.
because look at the way it's rotating. If it's rotating it now, as it rotated it like that, it's not meant to be able to touch the metal that is there. Because in
Yeah,
reality, that's not possible. So that's why I say like there has to be some form of constraint. So that I'm asking like how
yeah.
you do that on this kind of design.
Okay. So what he's asking Muhammad is that you just constrain it in such a way that it looks more realistic. You saw like you just like you bend the, let's call it the ball. You see
Okay,
when
wait.
when
I
you
tried.
bend it.
Yeah, he's saying like we have that it is moving inside that part, right?
Yeah.
Okay.
Yeah.
So wait, we will use
Okay, I
the
get you.
tangent made, so then we can see what this one with like this face, and we use tangent mate. Okay, so I think he's saying about that. No, we can't use the tangent mate.
And but
Okay.
now I'm asking like, what means can you use to constrain that? Because if you do it like that, there will be like a collision there. So is there a way you can, like the same way you use limit for the previous example to stop it at that place? So is there maybe a limit
Yeah.
that can be done for something like that?
Yeah,
Like we
depending
can
on the
use
technology.
angle mate, I think there. Okay, so to limit this one. Okay, so this is the another question. So unfortunately I cut the first question which I make, so that's why this is moving again and again. Okay, so this is not properly defined. Okay, this assembly is not properly defined. So the assembly I made, unfortunately I closed that assembly, so that's why this is moving.
And I'm just asking, like, so in case, because like people, like let's say people can come across designs so that have like something like that. So like you have to know like how to be able to like add some limit, even if there's a freedom it can move, it's a spherical joint, but like a way to be able to constrain it so it will not have collision with like some other parts. So that was just wondering if there was any kind of mate or something like that can constrain spherical joints. So that was like the question that I was just asking.
No, that's a nice question.
Like we look that we limit this circular face. Look, we limit this line with that face. Okay, so we use first limit there that this circular disc will not move in, like it will not rotate. Okay, we limit this circle. We need to limit that, and also we need the distance made there, so we limit this one at that place. So I think we can't limit this one with this. Okay.
Okay.
Okay, because there is nothing there. We add some angle there. Okay, or some like is underdefined, so that's why.
Okay. So David, I think was it okay for your question? Muhammad managed to give you everything clearly.
Yeah, it's okay.
Thank you very much, Muhammad. And the only thing you need to understand, David, is that we are not. He was just doing some representation of mates, you see.
Okay.
But if he was actually designing it, it would have been very different. Understand?
So this is my like first meeting. Okay, and there's some language barrier, so that's why I think I try to explain all the things. Okay, in easy way. Okay. So.
Yeah, I think we had the last another question. Or I didn't see it. I think there was another question, and the question was, I don't know. Let's just try to see it.
Question about the width.
Yeah, I think it was about the width.
Okay, so who is asking that question?
I don't know what's
I think he deleted the question.
he deleted the question. Okay. I was wondering.
So I tell about the distance made. Okay, brother. So how can we add the distance made there? So first we go to the advanced made, then we select these two faces. Okay, you can see that this first face, this second face.
Your SolidWorks screen. Your SolidWorks screen. Please.
Oh, okay, wait.
Yeah.
Sorry. Share screen, window, SolidWorks share. Okay, so you can see that how can we use the distance mate? First, we go to the mate and then we go to the advanced mate. Okay, we go to the advanced section. This one, okay, this advanced section, we select these two faces. So first face is this backward face, and second face is the like this front face of this rod. Okay, then we go down. There is the option of the distance. Okay, we specify the distance 0.02 meter. Okay, if we go in more advanced, we can use the maximum and the minimum distance. Okay, like if we know the distance, how can it a maximum move when it this circular disc rotate? So if we know the distance, we put their maximum distance like 0.3 or 0.4, and then there's a minimum distance which is 0 or 0.2. So when we know that the distance, we can easily give the advanced distance made. Okay, so in that way we can give that these distance made.
I hope it answered the question of Muhammad Umer.
Okay.
Sorry if I'm not pronouncing it very well, but I hope it answered your question. Okay, so we are wrapping up. So for those who did not send your emails, you can send it because you're already wrapping up. I got the email of those who sent. Oh, okay. There are others for sending. Okay. So you are going to have the recordings for the session, and we are going to post it in our LinkedIn page, and also you're going to have it in our YouTube page. For the different pages, I will just pin. Let me just pin the links to the different pages. Let me just pin the links. And one thing we have discovered is that, many of you, when you watch our videos, you don't really subscribe to the channel, but the subscription really helps us a lot because it helps us to bring a lot of good presenters like Muhammad. It helps us to also bring very important SolidWorks presenters that have been presenting, let's say, the 3D experience, all of that. So we would appreciate if you could subscribe, and actually even join the channel, comment. It's always something that's very positive. And give your feedbacks if you don't like the quality of the videos, if you don't like anything you don't like. So let me just copy the different. Let me just copy the different links and paste it here. Okay, please. And apart from that, Muhammad, would you like to, let's say, do you have something additional to say?
Okay, so thank you so much for joining, everyone. So that's it from my side. So if you want more information about assembly modeling, I can share some links with you. So wait, I will share paste some link in the comment section, so you can easily learn the basics of the mates. Okay, so wait, I share the link. Okay, in your introduction to SolidWorks mates.
And also, like I was saying, for the certifications, it will depend. Sometimes there are certifications that are available, and sometimes they are not. But one of the most important things is to share your email, because when we have your email, we send to them. And in case there are any certifications that are available, you will get, I will get you notified. So that's the most important thing. But sometimes, it can also take time. And for those who are requesting certified professional advanced certifications, they are not available now, because I had some couple of requests for those who needed advanced certifications. They are not really available now. So when they will be available, I will let you know. And the recordings will be available, I hope, this week. We also had an event with the Mansour work. It was a co-host event, so you also check that. And yeah, this is the link. This is the link that Mohammed have sent, and that's my link that I will pin to.
Yeah.
Okay. So for you, in fact, you can follow us on YouTube. You have the recordings on our YouTube channel. In fact, we are wrapping up, and thanks to Mohammed, and thanks to everyone. In fact, thanks to everyone who has been here. Thanks to everyone who has assisted in the event from the beginning to the end. And we had a wonderful presentation. Mohammed, for the first presentation, it was really good.
Thank you so much. Thank you.
And I hope to get you in our next sessions. Maybe
Okay.
you will find assembly modeling mastery, or maybe another one. So
Okay.
let's wrap up. Have a nice day, and thank you so much for your presentation.
Okay. Thank you so much. Okay.
So everyone, have a nice day. Bye.
Okay. Bye-bye.